Hi students, in this video I'll be covering problems 1 and 2 on your test 2 review. For number 1, you've got a combination of using two different strategies to solve a quadratic equation, using two methods here, quadratic formula and completing the square. Please remember that when you're solving a quadratic equation, what it means is you're finding where the parabola hits the x-axis. Alright? So for number 1, in order to use our quadratic formula, we do want our equation set equal to 0, which means we're going to need to subtract our 2x term, our linear term, from the right side to the left, and we'll have 5x squared minus 2x plus 4 is equal to 0. Remember, your quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Our a for 1a here, our a value is 5, our b is negative 2, and our c is positive 4. So we're going to start by substituting in here. X equals the opposite of b. Well, the opposite of negative 2 is positive 2, plus or minus the square root of b squared minus 4ac. Remember, you learned that your discriminant is your b squared minus 4ac. I recommend finding that and then plugging it into here in your calculator. So if I do go ahead and write out what my discriminant is, my b is negative 2. I need to make sure I put parentheses around a negative b value, minus 4 times a, which is 5, and c, which is 4, all over 2 times a, where a is 5. At this point, I want to go ahead and find the value of my discriminant. So I'm going to type in negative 2 squared, and yes, I have to have parentheses, minus 4 times 5 times 4. And I get negative 76. So we end up with 2 plus or minus the square root of negative 76 over 10. Your job at this point is to simplify the square root of 76. We recognize that if our discriminant is less than 0, which it is, it's negative, then therefore we'll have two imaginary solutions. So I'm going to think about breaking down 76 by dividing by 2 because it's even, and I can divide by 2 again because 38 is even. So if I come over here to the side, the square root of 76, I'm going to get 2 times 38 and 2 times 19. We should recognize that that simplifies into, since we have a pair of 2's, the 2 comes out, 2i square roots of 19 over 10. What we should also recognize is that 2, 2, and 10 are all divisible by a common factor of 2, so we need to reduce. So we should end up with x equals 1 plus or minus I square roots of 19 over 10. So it might seem like a lot, but we've got to make sure that we know how to simplify the square root of a negative to get our complex solutions by completing this by quadratic formula. Since we're on the roll with quadratic formula, I'll go ahead and apply the same here. We need to make sure that for c, we have quadratic term, linear term, and constant term on the same side together, so it's set equal to 0. Sorry about that. Computer's kind of slow. So let's go ahead and identify our A as 2, our B as 9, and C as 7. When I substitute into my formula, x equals the opposite of b plus or minus the square root, b squared minus 4 times a times c, all over 2 times a. I'm going to simplify everything, but then type my discriminant part in my calculator. And I get 25. That I can actually take the square root of. So I'm going to end up with negative 9 plus or minus 5 over 4. Negative 9 plus 5. So recognize this is two solutions. You've got negative 9 plus 5 over 4. And negative 9 minus 5 over 4. where negative 9 plus 5 is negative 4 over 4, which would give us negative 1. And negative 9 minus 4 is negative 14 over 4, which reduces to negative 7 over 2. So these are our two solutions, negative 1 and negative 7 over 2. Next, going on to completing the square, we need to remember that for completing the square, we need our quadratic term and linear term on one side with our constant on the other being subtracted. So in this case, we do have our quadratic and linear term. With this plus 28 needs to be subtracted. Remember, our next step is to complete the square, so we'll put in plus blank. Negative 8 minus 28 is negative 36 plus blank. Our next step is to take half of b and square it. So if I come over here and do 12 over 2, I get 6. If I square 6, I get 36. So I'm going to put those in my blank. So at this point, next I factor. So we'll have p, remember it's square root, keep the sign square root. So p plus 6 quantity squared equals 0. If I take the square root of both sides, I'll have p plus 6 is equal to positive or negative 0. But of course, I can't really add or subtract 0. So I'm just going to have negative 6. I'll just write that up there just so you see it. So p is negative 6. Now remember, any of these we can verify. So let's say I take this and I let p be negative 6. So I can do negative 6, store that as x, and then plug it in here, and if negative 6 is the correct answer, it'll come out to equal negative 8. So I'm typing in x squared plus 12x plus 28, and I get negative 8, so that shows that my answer does check out. Another thing you can do is set this equal to 0 and graph it. So x squared plus 12x plus 28, if I add 8, so it'll be equal to 0, oops, then I can graph it, and you should see that it crosses here at negative 6. You can verify it on our table also, negative 6, 0. Alright, so for part D, for completing the square, remember you don't want to get started until your quadratic term has a coefficient of 1. So that'll give us n squared plus 6n plus 5 is equal to 0. Now I want to move my linear term over, and I know I'm going to have to complete the square, so I'll have n squared plus 6n plus blank equals negative 5 plus blank. Half of 6 is 3. 3 squared is 9. And then I take the square root of both sides. I'll get n plus 3 equals positive or negative 2. If I subtract 3 from both sides, n equals negative 3 plus or minus 2. So I've got two solutions, negative 3 plus 2, which will equal negative 1, and negative 3 minus 2, which will equal negative 5. Both of these are my solutions. Alright, so for 2 it says, describe how the determinant or discriminant helps you determine the number and types of roots. So remember, there's 3 possibilities. You could have a parabola that crosses the x-axis twice, and in this case, we know that our discriminant is positive. So we can put up here, if the discriminant is greater than 1, greater than 0, there are 2 real roots. Another possibility is if it bounces off the x-axis, meaning we have a multiplicity on our factor. So for instance, like y equals x minus 2 quantity squared, it would touch the x-axis. So we call that a repeated solution, but that happens if our discriminant equals 0. So if the discriminant equals 0, there is 1 repeated real root. And then the last possibility is if it doesn't touch the x-axis at all. So that occurs if our discriminant is less than 0, meaning it's negative. Then there are 2 imaginary roots. Okay? So remember, your discriminant is the b squared minus 4ac part that we talked about earlier in your quadratic formula, but this is what I expect you to do in terms of describing. So you can write it in paragraph form or draw a picture and describe what it is, but please make sure you use a complete sentence. That completes numbers. Actually, before I do that, I'm going to just go ahead and do number 3 because this should be pretty, kind of ties into the same topic. So for number 3, you're asked to find the linear or constant term that would complete the square. So remember, to complete the square, we take half of b and square it. Well, 7 squared is 49, and 2 squared is 4. So that results in a perfect square trinomial. If you think about it, what we did here is we took half of b, so we divided by 2 and squared. So we did divide by 2 and square. Well, if we're trying to find our linear term, then we do the opposite. The opposite of square is to square root. So the square root of 49 is 7. And then instead of dividing by 2, we do the inverse of dividing by 2 and multiply by 2. So if we multiply by 2, we actually get a linear term of 14x. So that concludes 1 through 3. Good luck.